Ready? Okay, listen, I have your quizzes. We're going to do that to you at the end of the class. Okay, before I want to see this topic. Okay, we're going to continue with implicit differentiation, but today, as I told you yesterday, we're going to see how to find the derivatives of the inverse trigonometric functions. So far, if you remember, I told you to cancel them. You have that in an activity. But now, I'm going to explain how to obtain the derivatives using what? Implicit differentiation and a little bit about trigonometry. I know you are experts, right? You're experts. I wish. I hope. Okay, then. But the first one. I'm aware that there are formulas for this in the formula and everything, but I need to know how to get them. Because in the quiz, you're going to get the derivatives for those with procedure, not with the formula. Okay? Yeah. I'm sorry, but I wanted to be that way. Fine. Y equal to r sine of x. In this case, for example, where we start, what was r sine of x? What was that?
The inverse of sine.
The inverse of the sine. Okay? The r sine of x comes from this property that is, for example, if you have y equal to r sine of x, the inverse function, that happens if sine of y is equal to x. It's like question and answer, right? It's like, for example, x squared, square root, division, multiplication, logarithm expression, exponential expression. Same situation. You have inverse operation, right? So now, in this one, for example, you have y equal to r sine of x. If I want to get the derivative, assuming that I don't know the formula, what would you do? We're going to change this into the inverse operation, which in this case is going to be what? Sine of y equal to x. Now, you know the derivative for sine, and you have a y, so we can apply implicit differentiation to find the derivative. So here, for example, sine of y, derivative will be what? Y prime times cosine equal to x derivative 1. Now we're going to isolate y prime equal to 1 over cosine of y, and we apply the identities to solve this. 1 over cosine was what? No derivatives. What? Secant of y. Okay? Now, this is not the answer yet. Okay? Because this answer is in terms of y. So far, I told you, yeah, the answer y is fine. But the problem is that if I want to find the real answer for this, I need to put this in terms of x. That is, no y's in the answer, just x's. So what do I do then? Now, I need to apply a little trigonometry to find that. How? Questions before continuing? No? No? Okay, perfect. So, what I'm going to do is I'm going to use right triangles to do that. From this expression, I'm going to start drawing a right triangle. Normal right triangle. The angle doesn't matter. But in this case, for example, that y here, this y represents what in my triangle? The angle. Very good. Why? Because remember that you have sine of something. That something is always the angle. So, the angle is going to be y. And what was the sine of the angle in the right triangle? What was the formula? Opposite over hypotenuse. So in this case, for example, that x, if I put a 1 over that, because x over 1 is x, that x is going to be what? My opposite. And that one is going to be hypotenuse. Okay? Now, using Pythagorean theorem, can I get the expression for this side? Yeah.
1 minus 6.
If you remember, Pythagorean theorem says a squared plus b squared equals to c squared. This is the hypotenuse. Raised to the square. If I want to select one of the sides, which one? Doesn't matter. One of the sides. If I do that, it will be a squared equal to c squared minus b squared. So a is going to be square root of c squared minus b squared. If I apply that into this triangle, what is the expression for this side? square root of 1 minus x squared. Okay? Now I have expressions for this side, and that side. And now I can change the secant of y into this. What's the secant of y in the triangle? Hypotenuse over adjacent. So the final answer is going to be y prime equal to hypotenuse, which is 1 over adjacent, which is square root of 1 minus x squared. And that's my answer. That's the derivative for this. You check the formulary, that is what you have. Okay? But it comes from this expression. Okay? That's, yeah, for example, it's the inverse property. For example, you have sine of an angle equal to a value. That means that r sine of the value equal to an angle. I'll give you an example. If I have sine of 90 the answer is equal to 1. If I have r sine of 1, the answer is 90 degrees. Or pi over 2, okay? Change to a change by the inverse operation.
Profe, entonces, en este caso, ¿por qué quedó la respuesta 1 sobre...?
Hipotenusa sobre adyacente.
Because I'm changing the secant of y by using the triangle. So y is the angle. So secant of that angle is hypotenuse over adjacent. So 1 over this. Yeah.
That triangle is always the same, or
No, it's going to change depending on the function that I have.
so sometimes we can have that triangle or
The size will change. So the placement of the size will change.
Okay.
We'll do another one and you'll see.
the equation is the same, the formulas, or
The Pythagorean theorem, but not this. Because that depends on the side. So if what is missing is the hypotenuse, then it's going to be different. It's not going to be the same.
Yes, but we're going to have 1 minus x squared.
No, we'll do the other one. And then next time you'll see what I mean. Yeah. Okay. Fine. Let's try to remember those things from trigonometry. Remember, sine of an angle. Sine of an angle is what? Opposite over hypotenuse. What's the cosine? Adjacent over hypotenuse. What's the tangent? Over adjacent. If I want to use the reciprocal for sine is cosecant. So it's for cosine, secant. And for tangent. So we're using those to do what? To apply, to build our own triangle. For example, if I have sine of y, that's from here, sine of y equal to x. So x over 1, y over 1, because it's x over 1 is x, the same thing. And by using that rule, that formula, I'm building my own triangle. So sine is opposite over hypotenuse. Opposite is x, hypotenuse is 1. Okay, it's going to be always like that. Not always. If I have something different inside of the argument, then the triangle is going to have different values. But the procedure is the same. Okay, we'll do more so you can see what I mean. Questions? No? So we're using implicit differentiation to do this, and then little trigonometry to do that. Remember, well, you didn't see this last semester exactly like this. Well, some of you did with me, but the other ones have the basis to do that. The basis to do this is not that much again. Okay. The next one. The next one is the arcsecant. No, arctangent. Arctangent of x. What do I do? Same procedure. First, I change it into tangent of y is equal to x. And then the derivative. Tangent of y derivative? y prime
times
secant square of y equal to 1. Y prime equal to 1 over secant square of y, and you can change if you want to, so y prime is equal to cosine square of y. Okay? Now, again, we need to build the triangle. But now it's tangent, not sine. So, this is my angle y, but what do I have? What's tangent? So it's going to be opposite, so over adjacent. So now the hypotenuse is going to be what? What is going to be?
The square root of x squared.
Plus 1. Not minus, plus 1. Do you know why?
Por la fórmula, ¿no?
Because of the Pythagorean theorem.
Sí.
Pythagorean theorem. But if you don't understand that, just observe. Pythagorean theorem says a squared plus b squared equals to c squared. The hypotenuse alone is going to be square root of a squared plus b squared. So that's why instead of a is the value, instead of b is the value, that's what you have. Yeah? So, the final derivative, y prime, is going to be, what's cosine? What is cosine? So, raised to the square. Y squared, we will have a square here. The final answer is going to be 1 over x squared plus 1. And that's it. Okay?
¿Por qué está así? Sí, cocina, ¿verdad?
Yeah. Okay, the last one. Y equal to R secant. This one, what do I do? Secant of y is equal to x. Then derivative. Y prime times
tangent squared.
not square. Not square. Just secant tangent. Equal to 1. Y prime equal to 1 over secant y, tangent y, and then if you want to, you can just rewrite that into 1 over secant is what? Cosine. 1 over tangent is cotangent. Then triangle. The angle, what's secant? Hypotenuse over adjacent. So that side here is going to be square root of x squared minus 1. Okay? So the final answer is going to be y prime equal to cosine, which is from this triangle, adjacent over hypotenuse times cotangent is adjacent over opposite. Simplify. So 1 over x square root of x squared minus 1. We usually need to add also an absolute value to make the function existent, not in every case. To do what? To make sure that the angle that we use gives you a positive answer. It's only in case we have that absolute value of x in this one. Okay? And that's it. Questions? Sure? So in the quiz, for example, I would like to find those derivatives, but without formula.
Siempre van esos tres valores, no debería decir suma, resta, tienes que sacarle porque no están dualizados. O sea, siempre va a ser x, 1 y raíz de x cuadrada menos 1.
Okay, well, those could change if the argument is different than x. That can change. So for example, if you have r sine of 3x, for example, you will need to use a chain rule for that, or something else inside. We'll do an example. But the idea of the process is always the same.
Pero ¿por qué x es valor absoluto?
Again, to make sure that the answer exists. And in this case, as an answer, not putting this would be fine. But the problem is that if I put a value depending on the angle, remember that the secant has restrictions, remember? Yeah, secant does not all real numbers. The secant, you remember the graph of secant has restrictions. So to avoid those restrictions that affecting the answer, you just put absolute value to make sure that it exists. Okay, that also happens also when you need to integrate, but that's in Math 6. Yeah, the other ones no. The other ones are squares. For the secant. Arc secant and arc that happens only because of this. To make sure that the angle that I have gives a positive answer. Yeah, so in this case, the value that I have is a positive answer. It's just a little extra that's the last. Fine. Okay. Can I read this? Okay, another example. Okay. What happens with this one? You have something different than x. R cosine of 5x squared. Exactly. So you need the full same process. No need to apply some strange chain rule because we're not applying the rule directly. We're applying the process. You apply the process, the answer is going to come directly with the process. So in this case, for example, you change this into cosine of y equal to 5x squared. And then the derivative. Cosine of y derivative? Equal to 10x. Yeah? Yes. Now, by dividing, so y prime equal to 10x divided by minus sine of y. And then we simplify, if you want to, it's optional, change this into the reciprocal. So it's going to be y prime equal to minus 10x cosecant of y. Why? Because if the sign is in the denominator, if you want to rewrite that, it becomes cosecant. It's still fine. At the end, you need to substitute with the triangle. So as long as the final answer is okay, fine by me. This is not necessary. It's optional. But I need to use a triangle. How do I build my triangle here?
You have your angle on y, adjacent would be 5x squared.
Yeah, adjacent will be 5x squared.
One.
1, and what about this side?
Square root of 1 minus 5x squared.
5x squared to the square. Right? If you want to solve it, solve it. So 5x squared to the square, 25x to the 4th power. Yeah, you can do it. But do you see y is to the square?
Yes.
So this square here belongs to this one. But the square outside It's because of the Pythagorean theorem. Yeah?
Sí.
Good. Then y prime equal to minus 10x times what's cosecant?
1 over
Hypotenuse over
1 over
La hipotenusa.
square root of 1 times 5x squared to the square.
Coseno de y igual a 5x cuadrado. 5x cuadrado.
Can I multiply, simplify? Yeah.
Es 1 porque es
10x
coseno
over
adyacente
square root of
sobre
1 minus.
hipotenusa. No hay nada abajo. Entonces, ¿qué es?
You can even indicate or solve it, fine by me, as long as the answer is correct. That's the answer. Yeah? We didn't apply chain rule. We just apply the process and the answer comes directly. Okay? Very good.
Habla por ti.
One more example? Okay, one more. Something a little more complicated. Yeah, a little. A little. Okay. Fine. This one, what do I do?
Y, tan y.
Tangent of y
Equals
2 square root of 3x. Then derivative. Yeah, well, we can rewrite that if you want to. The 1/2. Derivative.
Ay, no sé.
Y prime times secant square of y.
Equal to derivative.
3.
3
3.
times
1 over
2 3x. Ah, no.
No,
No, it's 1.
Que se cancela. Queda 3, entonces queda 3x a la menos.
Here you have a chain rule. Derivative 3. Derivative is the 2. 1/2 3x minus 1/2. Can I simplify? Yeah. Y prime secant square of y equal to simplify. So this becomes 3 over square root of 3x. Yeah? Now what? You isolate the y prime, yeah? So it's going to be y prime equal to 3 over square root of 3x times secant square of y. What did I put in the denominator? Because he was multiplying, then comes to the denominator because it's divided. Yeah. Do I need to change this into cosine? If you want to. If not, that's fine. But I will see what happens. Times, no. We build a triangle. So on the triangle you have tangent, so it's opposite over adjacent, so opposite is going to be 2 square root of 3x, adjacent is going to be 1, and the hypotenuse?
Square root of 1 plus the 2, no, 4,
12x.
Do you understand why? Yeah, that's the square. 4 plus 3, 12 x. Yeah? No. A ver. Si elevas 2, 3x al cuadrado, lo que va aquí adentro, ¿qué
4
sería?
raíz de 9.
4, 3x. 2x. Okay? Answer. Y prime equal to
3 times 1 over square root of 1 plus 12x squared over 3x.
So finally, 3 over the square root of 3x times 1 plus 12x.
yeah. That's it.
That's it.
Yeah. Question? ¿Sí les queda claro? Fíjense, esto no está tan difícil en todo caso porque nomás es aplicar implicit y esto que es nuevo para ustedes, pero realmente como les dije, o sea, no es nada difícil, que trigonometría pues ya lo entienden, que es lo básico, ni siquiera es algo complicado como identidades o algo así, simplemente es reescribir. Aunque no lo vieron tan simple tal cual esto, de todas maneras no es tan difícil esto. ¿Okay? Nada más es reescribir y ya. Ustedes están, pero ya se la saben, es lo básico de la trigonometría. Good.
¿Cuál dirías que es el tema más difícil de todas las mates que llevas? Identidades. ¿Te acuerdas con Cari?
Que te imprimamos.
Extra.
Listen, in the activity 3.4.1, there are no examples like this one. So I'm going to add more exercise that you need to do. 4 more. You need to do that whenever you do the activity. Okay, and they're going to count from this activity. Yeah. But wait, you need to practice this because this is going to be in the quiz. I'm going to add it to the quiz. So you need to follow. No, it's 30. Yeah.
Are we going to add more topics?
Okay, continue with activity, please. Okay, listen. I'll get back to you the quizzes. I'm gonna do the quizzes and then you may leave, okay? Sophia, Mia. Paola. Sebastián. Chelsea. Sebastián.
Después